Hello dear students, welcome to Pen and Paper Chemistry on YouTube. As the name of the channel says, pen and paper is an essential condition to attend lessons on this channel where we cover organic, inorganic, physical and general chemistry. The only thing expected and requested of you is to share this gift of knowledge if you are able to connect to it, and if by the end of this video there's a smile on your face, right? Okay, let's get started with the properties. In the previous video, we've already spoken about nucleophilic addition reactions and the mechanism involved in it. It's a complete detailed video. In case you've missed it, you can always go ahead with it. And now we're going to write the individual reactions wherein carbonyl compounds show nucleophilic addition reactions. And as I said earlier also, pen and paper, if you write the reactions with me today, you will definitely find this topic so much easier. The first reaction that we've got is the nucleophilic addition reactions and addition of HCN, hydrogen cyanide, in basic medium giving a cyanohydrin. Very simple. What you do is transfer the electrons, negative, positive, break down the reagent, positive and negative. Negative goes to positive, negative, positive, and just connect the two. Please don't forget the basic medium, that means OH negative, in which the reaction takes place. Now what I have done is I have just taken a general compound. Now these compounds are known as cyanohydrins. It's the common name, right? There's a cyano group and there's an OH group, hence the name cyanohydrin. Would you like to give it the IUPAC name? What do you think would be the principal functional group and what will be the secondary functional group? Yes, we are going back to Iupac nomenclature of compounds. Have a look at the priority list and let me know what will be the name. Cyanohydrins, if you remember, are very useful synthetic reagents. You can convert them into amides because your CN group over here is very useful to be converted into an amide. It can be reduced to an amine. It can further be hydrolyzed to an acid. That is why they are very useful synthetic compounds as well. More of that later. Let us write the reaction now. Go ahead. Now it is up to you to complete these reactions. HCN. So first reaction of methanol with HCN. Second reaction of ethanol with hydrogen cyanide. Don't forget the reaction condition, basic medium. Third reaction, propan 2-one or acetone as we know it in the common terms, HCN, in a basic medium. Please complete these reactions. Break it down. Positive, negative, positive, negative, positive to negative, negative to positive. As simple as that. This topic is a little lengthy, but then you will realize that by the end of it you would have completed a major portion of your organic chemistry first of all, and secondly you would have covered two topics, not just one. So we are not just covering aldehydes, we are covering ketones as well. Right, now when it comes to the IUPAC nomenclature, what do? Our CN group gets priority over here. This is the principal functional group. Yes, I've given you a hint over there. Now go ahead and number it and name the compound. You remember the naming that I taught in the IUPAC nomenclature. So you have the word root, you have the primary suffix and you have the secondary suffix. So word root, because there are two carbon atoms, my word root will be eth. Right? Now it's saturated, so ane. The Cn is the secondary suffix. So what's the suffix for it? Nitrile, right? It is at position number 1. But you notice we have not considered the OH as yet. So what did we forget over here? Yes, the primary prefix over here. And what will be the prefix? There's OH group. So this will be 2-hydroxy. Why did I put the 2 over there? Yes, it's the locant. It is attached to carbon number 2. So putting this name together, how will we name it as? We will call it as 2-hydroxy. It's a name, so starting with proper, with a capital letter, 2-hydroxy ethane nitrile. Yes, commonly known as cyanohydrins. This way you can go ahead and name the other 2 compounds as well for practice, or otherwise in the common system we also call it as acetaldehyde cyanohydrin, right? Same way it will be acetone cyanohydrin, but in your best interest it is better to write the Iupac nomenclature. If you notice, in each of these I've put OH negative. Now what does the OH negative do? It's the basic catalyst. A very important condition of this reaction is the basic medium, because in the presence of the base this reaction is extremely slow. No OH negative, the reaction is very slow, almost negligible. So what do we do is we need a catalyst, and that catalyst is the base. Also another point in this reaction, the hydrogen cyanide, the hydrocyanic acid. So when you go to the laboratory, you'll never find a bottle saying HCN, right? Why? It's very unstable. So what do? Is we generate it in situ, and that means in the reaction mixture itself. I hope I've got the pronunciation right. In the reaction mixture itself, right? So how do we prepare it? We take sodium cyanide NaCN in excess, and there is the double decomposition with the help of a dilute acid, plus with minus, as simple as that. So we will have NaCl and HCN, which will react with our carbonyl compounds. Now here, as I said, the OH negative is required. Now where does the OH come from? NaCN plus HOH. The sodium cyanide gets hydrolyzed to release Na positive, OH negative, and we will have HCN here, right? The OH negative over here keeps the solution basic and acts as a catalyst, right? Done. Have you written these reactions? Without writing, to be honest, there is no point in watching this video, because again you'll be blank and you'll be looking for another video to understand aldehydes and ketones. So please write it down. Next is addition of sodium hydrogen sulfide, which was earlier known as sodium bisulfite according to the previous system of naming. Bi stood for hydrogen, so it is sodium hydrogen sulfite. Notice here ITE, not ATE. That is why it's NaHSO3. If it was sulfate, then we would have put NaHSO4, right? Sodium hydrogen sulfate. So go ahead, now write the reaction. Again, I would say keep things simple. Just take the positive here and the negative here. Go ahead, attach the positive to the negative, and what we get is an addition product. Now it's okay as long as the aldehyde is there. So I have your HC. So again, positive, negative, positive. So we'll have your OH and SO3Na. Now if you see, this carbon is not so much crowded and it is able to accommodate the SO3 to itself, but the problem comes up when we have a ketone. Now this is already crowded. Look at the addition product which is going to be formed here. CH3, CH3, and we will have COH and then SO3, negative Na, positive. Well, look at the way that it is crowded. Oh, there is alkyl group over here, then this bigger molecule. So what happens is, it says, okay, let me lessen your burden. So what they do is they swap places over here. The proton gets transferred. There's kind of an exchange. The proton gets transferred to the SO3 negative. So with the result, the product that is formed over here is SO3H, and the Na goes to the oxygen. So there is, internal transfer, SO3H, so that it's equally distributed. My seesaw is balanced. So if you notice over here, I've tried to depict it in the first step itself. So we know that the first structure is predominant in the case of aldehydes, whereas the second structure is predominant in the case of ketones, right? Would you like to complete the second reaction yourself? That is ethanol with sodium bisulfite. Now, go ahead. I'm waiting for you to complete it. Okay. CH3, COH, SO3 negative, Na positive, and we have H over here. Right. Now, these form the product formed over here. These are white crystalline solids over here. So with the result, I can use this particular reaction as a test for the carbonyl compounds. We can also use to purify the carbonyl compounds. So carbonyl compounds can be identified from those organic compounds which do not undergo reaction with sodium bisulfite. So you remember alcohols, chloroalkanes, haloarenes, they never reacted with sodium bisulfite. So whereas our carbonyl compounds are reacting with sodium bisulfite, giving us the bicrystalline solids, that is why we can use it to test. We can use them to separate as well as purify these compounds from other non-reactive compounds. The next reaction is one of my favorites, Grenia's reagent, most useful synthetic reagents that you can get, and the reaction takes place in the presence of dry ether. Now you know the routine because we've done Grenia's reagent as a separate topic. Now you'll appreciate why, although in your curriculum Grenia's reagent is not mentioned separately, but we have a separate video on that, because every chapter, every topic, every organic compound preparation and properties will involve Grenia's reagent. While I'm doing the talking, why don't you write the reaction? You remember? So we'll have the positive here, we'll have the negative here, right? Positive goes to negative, negative goes to positive, connect it and then hydrolyze in an acidic medium. So OMgX gets converted into, so we'll have H and OH, we'll have the basic magnesium halide as the side product, and of course OH group. What functional group? Yes, it's an alcohol. What type of alcohol are you getting in each of the three cases? Complete the reaction and tell me. I am not going to complete the reaction right away. I would want you to complete it and then we will match our answers. Addition of monohydric alcohols to aldehydes and dihydric alcohols to ketones. Monohydric, one OH group. So ROH or C2H5OH, it's a monohydric alcohol, one hydroxy group, right? CH2OH, CH2OH, two OH groups over here. Hence, this is a dihydric alcohol. CH2OH, CHOH, CH2OH. Glycerol, glycerine, three OH groups. Hence, it's a trihydric alcohol, right? Now, monohydric alcohols react with aldehydes and dihydric alcohols react with ketones to give us products which is known as, in the case of aldehydes, it's known as hemiacetal. Now, this hemiacetal is unstable. Now, how is an hemiacetal formed? Just form the products. Complete this reaction. Then you'll know what I'm talking about. Remember the routine. So we've got the negative, we've got the positive, we've got the negative, we've got the positive. I'm keeping it simple, no delta sign, just to keep, my board clean. So H, H, C, and then we'll have OH and OC2H5. Now we've got an alkoxy group and an OH group. Now this type of a combination is not very stable, and this category of compounds are known as hemiacetals. Semi-acetal means when you have two ethereal groups, OC2H5 groups attached, two alkoxy groups attached on the carbon atom over here. So go ahead. Now next step of the reaction, again dry HCl. What will you get over here? H, C, H, and of course, don't forget the alcohol, C2H5OH, and we will have OC2H5 and OC2H5, right? So, two alkoxy groups attached to the carbon, and so you can name them accordingly. Ethoxy attached to one carbon atom. So one carbon means what will be the word root? Meth, right? So 1 dimethoxy methane. Yes, Iupac nomenclature. Of course, that much detail may not be required by your syllabus. The general name of this class of compounds is acetals, right? Now, interestingly, the acetals give us back the original carbonyl compound on being treated with a dilute acid. That is why we've shown this process with a reverse arrow. And on the addition of dilute acid, again we are getting the original carbonyl compound from the hemiacetal or the acetal. Now try completing the second reaction yourself. One thing that I would like to point out over here, many a times the students are found to be writing the above products as OH and then they write C2H5O. And then they expect a tick and a full mark over there. But what they get is a wrong and no marks over there. Why? Marks will come if you understand the logic behind it. See, if you try to expand this C2H5O, what is it? C2H5O. This is what you are doing, right? 1, 2, 3, 4 and 5. Now, there is no free valency on this carbon or this carbon. So, how will it get attached to the carbon over here? It can't. Whereas, my oxygen is still hungry, it's got one more bond to form. So, which side will the bond be formed? Will it be formed through oxygen or will it be formed through carbon? Think about it. Okay, now go ahead, form the product over here. In the case of ketones, on the other hand, they, as we said, react with dihydric alcohols, right? Okay, I'm going to keep the things very simple. I'm going to simply remove the water from here. My lesson becomes easier, right? CH3C. Yes, not just my lesson, it becomes easier for you also to remember such a vast number of reactions. And don't forget the single bond between the two CH2 groups. There we go. So that means it's a cyclic compound formed from a ketone. So this class of compounds is known as a cyclic ketal. And again, on treatment with a dilute acid, we will get our original ketone back. Now let's observe something interesting over here. Look at the number of alcohol molecules being used up in the first two, where you've got aldehydes. So I took the example of methanol here and ethanol. How many alcohol molecules did we use? So we used one molecule over here and one molecule over here. In other words, monohydric alcohols to aldehydes, the ratio is 2:1. For every one molecule of the aldehyde, you are using two molecules, or you require two molecules of the alcohol. Whereas in the case of ketones, only one is sufficient. So here the ratio would simply be 1:1. Now we've been saying all the while dry HCl has to be there in the reaction mixture, right? So what is the role played by HCl? HCl simply comes, it entices the O with the H positive and tells, okay, see, I can share the electrons with you. With the result, oxygen is happy to pull those electrons away from carbon, and in turn my alcohol can easily come and attach itself to the carbon. In other words, the presence of HCl is simply helping to improve the electrophilic nature of carbon by protonating the oxygen of the carbonyl group. To make it easy for you to remember and write it down, I have written it over here. Dry HCl protonates the oxygen of the carbonyl group, helping to make the carbon more electrophilic, right? So H positive pulls the electrons of oxygen. Oxygen in turn, tug of war, remember? That's the example we gave. So the alcohol can easily attack the carbon atom over here. We get an unstable product. So alcohol tells its hydrogen boss, thank you so much for helping. Please kindly leave. And so we have the hemiacetal being formed here. Okay, did you complete these reactions? Addition of Grenia's reagent followed by acidic hydrolysis. If you have not, then please watch the video and practice the equations on the playlist Grenia's reagent preparation and properties, and you will be good to go and you will be much more confident about your work. Next video, we continue with nucleophilic addition followed by elimination. So take a short break and come back for the next one. See you there. By the way, if you are surely smiling at the end of this video, then please don't forget to share it with your friends and classmates, because sharing is caring. Help to make chemistry easy and fun to learn for everybody. Thank you so much.